In this video, I will explain how to set up an automatic watering system for your indoor plants at home. Imagine you are going out of town for a week or two and you don't want to depend on your neighbors to water your plants. In such cases, an automatic system like this can be very useful. This idea works not only for indoor plants, but with small modification, it can also be extended to larger irrigation system. Let's start with the basic concept. In most homes, we already have an overhead water tank which is automatically filled using a water level controller. So this becomes our primary water source. Initially, I thought of using a solenoid valve connected to a pipeline that distribute water to individual plants. Idea was to control the valve using a controller, turning it on and off at specific intervals. This approach works in theory, but during testing I noticed a problem. After a few cycles, the solenoid valve started through leakage. This is a serious issue because it can lead to overwatering and unnecessary water wastage. I tried a few different solenoid valves from different manufacturers, but the reliability was not satisfactory, so I decided to drop this idea. There are ready-made solutions available online like drip irrigation timers which include built-in valves and programmable timing. This can work well, but I wanted a more flexible and customizable setup. So I moved to an alternative approach. Instead of directly controlling water flow using a valve, I use a separate storage tank and a small water pump. The idea is simple. Store water in a tank, use a pump to supply water to plant, control the pump timing using a controller. This method avoids leakage issues and gives better control. To enhance the system further, I also thought of adding remote monitoring. With this feature, the system can send soil moisture data as SMS to your mobile phone. So even if you are away, you can monitor whether your plants are getting enough water. Now let's look at the components I used. For plumbing, instead of building everything from scratch, I purchased a ready-made drip irrigation kit. This made the setup much easier. This kit includes a 16 mm main supply pipe, 4 mm feeder pipe for individual plant, connectors like elbows, T-joint, straight joint, flow control valve, end cap and emitters, tap connectors. This particular kit supports around 30 plants and similar kits are available based on your requirement. For water storage, I used a 100-liter PVC tank. For pumping, I selected a 18-watt submersible pump commonly used in aquariums or small fountains. Now comes the control system. If you want a simple solution, you can use a digital timer socket where you set on and off timing for the pump, but this has limited flexibility. So instead, I built a custom controller using Arduino. Here is how the system works. The Arduino Uno acts as a brain. A DS3231 RTC module provides real-time clock data for Arduino. An SSR solid-state relay is used to switch pump on and off. A 5-volt DC power supply powers the electronics. A glass fuse is added for safety. A piezo buzzer is used as an optional alert indicator. Since the pump runs on 230-volt AC, the Arduino operates on 5-volt DC. The SSR helps in safely interfacing between them. Finally, this is a complete setup. You can see the Arduino board, RTC module, relay module, power supply unit, fuse protection, input and output connection for AC power. With this setup, you can fully automate your plant watering system and even expand it further with sensors and remote monitoring. Now let's understand the program used to control the automatic watering system. At the beginning, we include two important libraries. RTC lib, which is used to communicate with the real-time clock module, wire library, which handles I2C communication. Then we create an object for DS3231 RTC module, which will provide the current date and time to the Arduino. We also define a boolean variable called action done today. This is used to make sure the watering happens only once at the scheduled time. Inside the setup function, the system initialization takes place. First we start serial communication for monitoring, then we initialize I2C communication and start the RTC module. Next we define two pins. Pin 2 is used to control the relay for the pump. Pin 3 is used for buzzer alarm. Both are set as output pins. Initially both the relay and buzzer are turned off. There are also optional lines to set up RTC time either from the computer or manually. These lines are usually used only once during the setup. After that there is a small system test. The relay and buzzer are turned on for a few seconds then turned off. This helps verify that the connections are working properly. Now let's move to the loop function which runs continuously. First the Arduino reads the current time from RTC module. Then it prints the current hour and minute to the serial monitor. This is useful for debugging and checking whether the timing is correct. Next comes the main logic. The program checks if the current time is 5 p.m. and if watering has not already been done. If both conditions are true, the relay is turned on which start the pump. The buzzer is also turned on as an indication. The system waits for 30 seconds allowing watering to take place, then relay and buzzer are turned off. After that, the variable action done today is set to true, so the system does not repeat the action again in the same minute. Finally, there is a reset condition. Once the time moves past 5:01 p.m., the flag is reset. This ensures that system will be ready to perform the watering again the next day. So, in summary, this program uses real-time data to automatically turn on water pump at a fixed time every day, making your plant watering system fully automated. Next, I will show you the components I purchased for building the controller and the overall setup. First, this is the AC to DC converter, which is used to power all the electronic components like the Arduino and relay module. Next, this is the SSR relay module. This is a high level trigger relay, which means when the Arduino gives a high signal, the relay turns on and operates the pump. It is a single channel relay. It can work with the DC control voltage anywhere between 3 to 24 volt. This module also has inbuilt resistive fuse for basic protection. This is the Arduino Uno microcontroller board, which acts as a brain of the system. You can also use other Arduino models if required. Here we have RTC module, which is a real-time clock. It communicates with Arduino using I2C protocol, which provide accurate time information. You can create a timing program using just delay function in Arduino, but the problem is if there is a power failure, the timing will reset. To avoid that, we use this RTC module. It also has an inbuilt battery, so it keeps track of time even when power is off. This ensures reliable operation. Now let's look at the actual setup. Here we can see the water storage tank, the control unit and pump discharge line. I have also added an extra outlet with a valve, so the system can be extended in future if needed. This is a submersible pump used to supply water. From the pump, water flow through the main header line, and from there small feeder line branch out to individual plants. There is also an adapter connector that link the main line to feeder line. At the end of each feeder line, there is a dripper which controls the flow rate of water to each plant. This completes the overview of components and setup. In this video, I have not covered the remote monitoring setup. In the next part, I will show you how to add remote monitoring to the system so that you can track your plant watering from anywhere. Thank you for watching.